In this video, we will introduce the concept of hypothesis testing. We'll do this through the use of several examples. Our first example, the original claim, the proportion of male golfers is more than 0.2. Basically, that's saying the percent of male golfers is greater than 20%. We have to have some basic things laid down. So we need to know the significance level before we begin the hypothesis test. It would be really bad science to pick a significance level after the test. So to decide what we're looking for after the fact, not a good procedure. So we have a significance level of alpha equals 0.05. This is the most common significance level. And then we're not doing the actual hypothesis test. We're just looking at it because this is our intro video. So the hypothesis test results in a p-value of 0.038. So let's make sense of all of this. In order to do a hypothesis test, we need to start with our hypothesis. And we know that there have to be two of them. So we have to have a null hypothesis, which we would call H0 or H0. And we have to have an alternative hypothesis, which we can call H1 or HA. In the null hypothesis, we always use our equal statement, and since this is a proportion, which is actually stated up here in the prompt, we're going to use P, the population parameter, and we would say the proportion is equal to 0.2. And in the alternative, we're going to capture this claim here, this more than. So we'll say the proportion is greater than 0.2. Now, for the p-value method, we're going to compare alpha and the p-value. So I look at my alpha level, which is 0.05, and I look at my p-value, which is given, which is 0.038. When I compare these two, the p-value is smaller. So I'm going to put that right in here. And so my alpha value is greater than my p-value. So we had a little rhyme, and in our little rhyme it says if the p is low, so the null must go. So what this means, our p-value is our low one, so we're going to reject the null. That is totally talking about statistics, and the average person is not going to understand what we mean when we say reject the null. So I need to go back and look at what does that actually mean. And to reject the null means that I am picking the null statement as the false statement. So the proportion being equal to 20% or 0.2 is not the case. The evidence that I had in the sample that gave me the p-value suggests that it is actually true that this alternative case. And the alternative case would say that the proportion of male golfers is greater than 20%. So our final step in this hypothesis test is to actually give the information in a way that makes sense. So instead of coming to a conclusion of just rejecting the null, we want to put that into words. There's a number of ways to word this statement. The first way that we could say this is with 95% confidence that the proportion of male golfers is greater than 0.2. That 95% confidence comes from our alpha value of 0.05. We could also say this in terms of significance. So we might say instead, using a significance of 0.05, the proportion of male golfers is greater than 0.2. Or we might say, at the 0.05 significance level, there is sufficient evidence to support the claim that the proportion of male golfers is greater than 0.2. So there's a bunch of little different tweaks with the wording, but we do want to take the decision that we made and put it into the context of the problem. Let's take a look at a second example. Here our original claim is that women have heights with a mean equal to 162.5 centimeters. And I'll never think in centimeters, so I converted that over to feet and inches. It would be 64 inches or 5 feet 4 inches. So that seems reasonable as the average height of women. But we're going to test it. So we're going to assume a significance level of alpha equals 0.05. And the hypothesis test results in a p-value of 0.1668. So in order to do a hypothesis test, we need to start with having some hypotheses. And so again, we're going to write, first we'll write our null hypothesis, so H sub 0 or H naught, and then we'll write our alternative, which can be either HA or H1. In this, we have a mean, so we're going to use mu instead of p like we did in the last one, so mu. Our null hypothesis is the equal to statement, so equal to 162.5 centimeters. And our alternative, mu, well, we don't know. Is it going to be less than? Is it going to be greater than? So we're just going to put not equal to 162.5. Some contexts give us the less than or greater than, or we can tell who would have a vested interest one way or the other. But here, we don't have any of that information. So now we're going to compare. So we want to compare alpha and the p-value. So my alpha value is given 0.05. My p-value is given 0.1668. And when I look at these two numbers, I can see that alpha is the lower number. So my inequality symbol goes this way. And so again, we have a little rhyme, and our rhyme says, if P is high, the null can fly. So that means P is our high one, and that means that this null one is the one that we think is true. The can fly here means can stand. And so we, in statistics words, fail to reject the null. And again, we have to put that in the language of the problem. So if we fail to reject it, that means we have evidence to support that the mean is actually 162.5 centimeters. And so a couple different wordings. We could conclude with 95% confidence that there is not sufficient evidence to reject the claim that the mean height of women is 162.5 centimeters. Or we could use the significance level. So using a significance of 0.05, there is not evidence to contradict the claim that the mean height of women is 162.5 centimeters. Or we could say it this way. At the 0.05 significance level, there is insufficient evidence to refute the claim that the mean height of women is 162.5 centimeters. Now, you'll notice in this language that all of the language is communicating that we failed to reject. The language never uses that we accept. Because just because we have evidence doesn't mean that we've actually proved it. Okay? We don't have evidence to refute it, but that's not the same logically as actually proving something. And so that's why in all of these wordings, we're saying that we cannot throw out this conclusion. We don't have anything that contradicts it. But in statistics, we never know anything to be 100% true, so we can't actually come out and say, hey, the mean height of women is 162.5. We just say we don't have anything that would contradict that idea.